This video focuses on how we can transform linear equations into slope-intercept form. In other words, we're going to work with some of the most difficult equations, the ones that are not in slope-intercept form at the beginning, and figure out how we could make a graph for those. Slope-intercept form is one way to write a linear equation. We've seen many equations in this y equals mx plus b form, where m is equal to the slope, whatever's multiplied with x, and the b is the y-intercept. Not every linear equation is going to be written in slope-intercept form, though. There are two examples in green and in purple here of linear equations that are not in slope-intercept form. When this happens, we cannot determine the y-intercept or slope right away like we can for the equations that are in slope-intercept form. This makes it more challenging to graph these equations. One option to graph these equations is to solve the equation for y. What we mean by this? We can transform the equation by using inverse operations to isolate the y variable. Last year you've done this already. Mr. Neville referred to this as peeling the onion. Once we do solve the equation for y, or get the y isolated, then our equation's in slope-intercept form. We can quickly graph using the y-intercept and slope. Let's look at two quick examples. The first, in green, is our equation y plus 5 equals 2x. It is not in slope-intercept form yet, but the only thing we would need to do to get it into that y equals form is to get rid of the plus 5 that's on the left side of this equation. We use an inverse operation, the opposite operations, to cancel things out. Subtracting 5 would eliminate a positive 5, and I'm only allowed to subtract 5 from the left side of my equation if I also subtract 5 from the right side of the equation. 2x and negative 5 are not like terms. As Mr. Neville would say last year, they don't have the same last name, so at the end this just becomes y equals 2x minus 5. Now we know the slope, which is 2 over 1, and we know the y-intercept, which is 0 and negative 5. A little more complicated in purple here, negative 9x minus 3y equals negative 15. Again, our goal is going to be isolating the y to get it all by itself. If we were peeling the onion, as Mr. Neville would say, or trying to get this y all by itself, the first thing we want to do is get rid of negative 9x. We could do that by adding 9x. Again, that has to happen on both sides of the equation. That simplifies the equation to negative 3y equals 9x minus 15. Now we need to get rid of the coefficient, the negative 3 that's multiplied with y, so we divide both sides of our equation by negative 3. On the left side, that gets us down to just y, isolates the y like we wanted. On the right side, it's important to note both the 9x and the negative 15 term need to be divided by the negative 3. When we do that division, we're left with y equals negative 3x plus 5. And now we realize for this equation up here, the y-intercept was a positive 5, the slope was a negative 3, but we couldn't tell that at first until we transformed or changed that linear equation into slope-intercept form.